Hello everyone, and I welcome you all for the today's session of the subject system programming. I am Mrs. Pragati Mahale, working as an assistant professor in the Department of Information Technology at AISSMS Institute of Information Technology. So today in today's session we are going to discuss about the assemblers and the type of the statements used in assembly language, which is from the unit 1 of system programming. So to start with the session, I would like to share with you I hope now my screen is visible to you, dear students. So today we shall start with the assembly language, and in this assembly language, as you know, you all have already studied assembly language in the earlier subject. We all know that assembly language is a low level language, right friends? So assembly language is a language which is machine dependent. It differs from computer to computer. So as the computer or the platform changes, the assembly language is also differs. So we say it is a machine dependent. Writing a programming assembly language is very easy as compared to writing a program in a machine language, which is, as you know, in terms of binary codes 0 and 1. In assembly language, we are going to use certain terms which we require very often. So let us see these terms that we are going to use in our program. So location counter is a basic term which is also called as LC. It points to the next instruction in the assembly language program. Literal is nothing but the constant value. Okay, so the value that we define for some of the constants that we may need in our program are called as literals. Symbols are the name of variables and the labels. In our assembly language source program, we need certain variables and also the labels. All of these are termed as symbols. Finally, the procedures are nothing but the methods and the functions. So in the assembly language, we write the assembly language. If you see this kind of statements, or let us have a look on this code. So you can see here there is one, let us see one example. Move a register comma x. So this are nothing but the statement in the assembly language or the instruction. So in this language, each statement has two operands. The first operand is generally a register, which may be A register, B register, C register, or D register, whereas the second operand refers to a memory word using a symbolic name or an optional displacement or a constant, or we can say a variable. Right, friends? So with this introduction to assembly language, let us come to the next point which we are going to discuss today, that is called as the assembly language statements. An assembly program contains three kinds of statement. One is the imperative statement, second the declarative or declaration statement, and the third type is the assembler directive. Let us go into details with all these three types of statements. So let us see the first kind of statement, which is called as imperative statement. Imperative means mnemonics. As we have seen earlier in example of assembly language instruction or a statement, the very first thing that you see this, for example, move R, it is called as a mnemonic code. That is, you don't have to write or remember or memorize a numeric operation codes. Instead of that, we make use of mnemonics that indicates what is the type of operations that we want to use. So here move R means we want to move some contents into a register. Similarly, read X. So read is a mnemonic which indicates to the assembler that we need to perform a read operation. When I say add a register comma Z means I am going to perform the operation of add. So in assembly language, we do have a table that is machine opcode table, which stores all the this kind of assembly mnemonic and their corresponding opcode. Okay, friends. So I hope that this word, the term mnemonic, is clear to you. Now moving on to understanding what is the imperative statement. An imperative statement, it indicates an action to be taken during the execution of the program, right? So like in C program, we write a statement of code inside a function or a class or some executable statements, we can say. Similarly, imperative statement are the executable statements, right? So imperative statement indicates the action to be performed during the execution of the assembly program. Okay, so each imperative statement typically translate into one machine instruction. So as you can see here, these are all action words: move R, stop, read, add. So it indicates some kind of action that the assembler has to take. So we also say call it call them as a executable statement. So whenever you see such kind of statement having action words, mnemonics, all those type of statements are comes under the imperative statement. Now let us move on to the declarative statement. Declarative statement are for reserving memory for the variables. Okay, so we can specify some initial value of the variable. So declarative statement, they comes into two types. One is called as DS. DS, the short for declare storage, and DC, the which is also called as declare constant. So DS is a declarative statement that reserves an area of memory and associate a name with that. Okay, we shall see the example in the next slide. Similarly, DC, we say declare constant, is a statement that constructs a memory words containing constants. Let us understand this with an example. Let us see the example of DS. So this is the syntax to write a declarative statement. We have a label which is optional. Then you write DS and then we mention the constant. Okay. So let us see the example X DS1. So how do you read this statement? I say X DS1 means I declare a storage of one word, and what I do, I associate the name X with that memory area of the size one word. Got it? So this specifies the memory in terms of word, and this memory is associated with the name called as X. This is called as the declare storage. Now let us see the example of declare constants. Let's see the syntax first. Again, label is constant. You say DC. Then we have constant specifying the value. So as you can see this statement Y, DC and 5. So here the name Y is associated with the memory word containing the value 5. You got it? How we read this particular statement. So why is the name associated with the memory which contains the value 5? So the programmer can declare constant in different forms. It could be decimal, binary or hexadecimal. Okay. The assembler converts them into the appropriate internal form. So dear students, I hope that you have understood this declarative kind of statement having two forms, declare storage and declare constant. Right, friends? The last type of assembly statement is the assembly directive. Assembly directive instructs the assembler to perform certain actions during assembly of a program. Some assembler directives are start, stop. So here assembly directive instructs the assembler to perform certain action. So start indicates to start reading the first line of the source program written in assembly language. Similarly, the directive end indicates the end of the source program. So this is how the directives, those instructions tells or instructs the assembly to perform certain operations or take certain action during the assembly language program. Now with this, these are some more advanced assembler directives like origin, equal, using, drop, LTORC, which we are going to study later in our unit 1. So let us now take one simple example, and with this example let us try to identify which are the statements, different type of statement in this particular code. Assembly language code, we have a simple code with just 8 lines of code. So in this assembly code, now we have to identify what are the three types of statements. Okay, so let us write those statements in this table. So our question is identify the type of statements. So what we are going to do is we are now going to have the first statement, start 100. What is this type of statement? Now you can see start. So what is this? This is the assembly directive. So this is the AD statement. So we shall write for statement number 1, it is AD. Now, which is the next? Move our A register X. So this is a what? This is the IS, that is imperative kind of statement because it starts with a mnemonic. So statement number 2 is of the type IS. Similarly, the third statement is again a IS. The fourth statement, add. Again, it is a IS statement. Statement number 5, move M. A register X is again a IS statement because it has a action word mnemonic which indicates assembler to perform certain action. Now let us go move to the next statement in our program 6, which says declare constant 10 and the name associated is X. Now it is an DS or DL statement, okay, because it has DC. So statement number C is a declarative statement, right? Now let us have a look on the statement number 7. What it says? Y DS1. Again, it is a DS or DL statement. So we shall write here DS. And the last statement, that is end. End is a assembler directive. So in the number 8 we shall write AD. So I hope that with this particular example you are clear with how to identify the type of statement in the given assembly language code. For a practice, We can again have one more small example. Here I have a code and my question, now we shall identify the symbols, the literals and the ADIS or DS kind of statements and also the labels in our program. So dear friends, are you ready for this particular example? So we will not only identify the three type of assembly language statement, but we shall also look for the symbols, literals and tables, right? So the first statement, as you can see, start 100. Again, you know that it is a AD statement, right? The second is the IS statement, loop move R. Again, move R mnemonic, so it is the IS statement. Add is the IS statement. This origin, as you know, it is AD, so it is the AD statement. L torque is again a assembly directive. Origin is again a assembly directive. Last, stop. Stop is not a assembler directive. Okay, it is a IS kind of statement. DC again a declarative statement. End is a assembler directive. Okay, in this program we have used various literals, symbols and labels. So we shall now put down all this in the tabular format. So let us have such a kind of table again. So the first statement start is a AD. As you can see, we have made a table. This is also a problem from the previous university exam, right? So in exam also you are given such a question where assembly code is given and you are asked to identify the different type of assembly statement. So you can just have such kind of table, and for each assembly language instruction you can make an entry. So first one is AD. Second, as we know, it is the IS statement. Here the number 2 we can say this is a literal, so we also make an entry in the literal table. Then the third is the loop move R A register comma N. So this loop is nothing but a label, so it goes into the label here and we make an entry here. Again, this is the IS statement and we also have a symbol here N. So in the symbol we make an entry N. Next statement, add. So it is IS statement. We have B register and this is nothing but a literal. Whenever you see equal means it equal and a numerical value, it is nothing but a label. So it goes here. Right friends. Next, origin loop plus 5. So origin is the AD, L torque is AD, again origin is the AD. We shall understand in the next lecture the meaning of origin and L torque assembly directives. Right now we are just understanding the three type of statements. The next statement is last, stop. So last here is a label, so it goes in the label, right? So last is a label which you can put down here, and again it is an imperative statement. NDC5, it is a declarative statement. End is what? End is a assembly directive. So this you make in the this, here you enter as AD. So for this particular given code, we have identified the symbol, literal, AD, type of statement and label, and that solution we have put down in this particular table. This is how you have to solve any assembly code given in the exam. You can mention the type of statements. So I hope, dear friends, the concept of types of assembly language statement is clear to you, and given any assembly code you are able to identify the types of statement and the symbols, literals, labels in the program. Thank you. If you have any doubts, you can ask the doubts. Thank you so much.